Hello everyone, I hope you are doing really well. Let's start with today's topic. Today's topic is ionic radius. It is like atomic radius. It is one of the most important topics in periodic properties. If not, it is at least as much important, if not more, than atomic radius itself. Okay. So what do you understand by ionic radius? There are two types of ions. We all know cations and anions. Cations are positive, anions are negative. There are two types of ions, positive ions and negative ions. So when ionic bond is formed, actually these ions, cations and anions, they actually touch each other like this. This is the positive charge, this is the negative charged anion, and they form one bond. This is the ionic bond, and this is the radius, ionic radius, that we are talking about. Radius of cation, the radius of anion. Okay, so what is it? Distance from the nucleus of the ion to the point up to which it has influence in the ionic bond. What does this mean? Distance from the nucleus of the ion. We are taking the nucleus of the ion, we are taking a distance up to the point where it has influence on the ionic bond. This is the ionic bond. This side is actually positive, this side is negative. So up till the point where it is positive, the positive side has more influence. Up till that point we take as the radius of the cation, and where the negative has more influence we take it as the radius of the anion. Okay, now we have studied lots and lots of ions. The scientists have studied them extensively, and there we have come up with two universal rules. Actually here universal rules are what? The size of cation is always smaller than parent atom. Okay, the size of anion is always larger than parent atom. You get it? A very universal rule. Cation is always smaller than parent atom, anion is always larger than parent atom. What does it mean? You have sodium and you have sodium plus. Cation is always smaller. So sodium will always be bigger than sodium ion. But if you have chlorine and chlorine anion will always be larger than the parent atom. Why is it so? Let us understand. Okay, we don't have to memorize, let us understand. Sodium we are taking, sodium has 3 shells, and here we have electron, 1 electron in the outermost shell. This is the nucleus, has the positively charged nucleus inside. Okay, now we are removing 1 electron. What happens? 1, 2, only 2 shells remain. There are 8 electrons right here. Okay, 8 electrons in the outer shell and 2 in the inner. This remains. So what we are doing, actually we have removed one extra shell from this sodium. So definitely one extra shell, the size of sodium will decrease as this sodium becomes positive. Similarly, in magnesium there are 2 electrons outside. If we take out one, okay, the positive charge in the center remains same, but the number of electrons that it has to hold is actually decreased. So it will pull this electron with more force than if there were 2 electrons to balance this force out. Okay, so that is why the size of this magnesium plus or magnesium 2 plus will actually decrease from the original magnesium ion. Similarly, for any positive charged ion, if we remove one electron, the other electrons will experience more force because the positive charge remains the same, the negative charge has decreased. That is why. Now for chlorine or for any anion for that matter, if we add one electron, like this is the positive charged, we have added one electron extra. Okay, we are adding one electron, so the positive charge is always remaining the same. Now this same positive charge has more electrons, more number of electrons that than it can control. Okay, so the pull will actually decrease. For chlorine or for any negative charged anion for that matter, the number of positive charge remains the same, but the negative charge, as it is increasing, the pull per electron or the effective nuclear charge is actually decreasing. That's why the size will actually, it will expand a little and it will increase. Okay, so now you can compare. If I give you questions like this, magnesium is larger or magnesium 2 plus, you can always say magnesium is larger. If fluorine is larger or fluorine minus, you can always say fluorine minus is larger. Like this we can do these kind of questions. Now let us talk about a special type of ions. Now look at this, the isoelectric ions. What are isoelectric ions? Ions having same number of electrons, as simple as that. The number of electrons are same, but the magnitude of nuclear charge is different. Actually there are different elements which have the same number of electrons. For example, let's take this example of S2 minus, Cl minus, K plus. Or now if you look at the number of electrons here, you will see that there are same number of electrons, but as these elements are different, the number of neutrons is different, the number of the nuclear charge, that is why it is different. Now why are we reading this? Because in NEET, one of the most favorite as well as one of the most simple questions that come from this chapter is actually to arrange these isoelectronic elements according to their atomic radius or ionic radius in that matter. So if we take like Mg2 plus, Ma plus, F minus, O2 minus, N3 minus, all these have same number of electrons. If you count the number of electrons, they are same. Okay, but as their nuclear charge difference, their ionic radius will be different. Now what will be the ionic radius of these? It is very simple. Always remember, cations will have less, anions will have more ionic radius. Okay, the minus charge, forget about everything that we have learned about atomic radius. You just have to look at the charge. If they are isoelectronic, remember, if they are isoelectronic, if they are not isoelectronic, do not just go around doing this minus and plus and then arranging. If they just first count the number of electrons. If they are isoelectronic, then don't look at anything else, just go look at the charge. The highest negative charge will have the highest radius, the lowest negative charge, and then the highest positive charge will have the lowest radius. Okay, so this is the rule. What is the rule here? An ion has always greater than neutral is always greater than cation. Always remember, for any question from this ionic radius, you have to apply this rule. If they are isoelectronic, anions will have the greater ionic radius than cations, and in the middle there are the neutral ions. Okay, why is it so? That it is very easily explainable by the same principle. Actually, this has nitrogen has way less positive charge in its nucleus and way more electron than it can actually hold. So the poor small nucleus positive charge is actually overwhelmed by the number of electrons that it is having. The electrons will try to run away from it, so the size will actually increase. And what about the Mg2 plus? This positive charge is very huge positive charge, and the number of electrons is very less, so it will attract these electrons like one parent. It will attract these electrons like crazy, and it will hold this electron, so the radius will actually decrease. Now there are some odd situations which are given in actually NEET, and you have to memorize these. What are these? Li plus and Mg2 plus. These are not isoelectronic. Because remember, Li plus and Mg2 plus is not isoelectronic. So how will we take out the ionic radius? We just have to memorize. Li plus actually has more ionic radius than Mg2 plus because of the positive charge. Li has smaller positive charge, that's why Mg2 plus has greater positive charge, that's why it is coming out like Li plus has greater ionic radius than Mg2 plus. Another one is, which was given, this is very favorite question actually, Fe minus, Cl minus, Br minus, I minus and H minus. Okay, what do you think? Which one has the highest radius? What is the trend of the radius? So any normal person, what they will do, normal students, H minus has smallest, then F minus, then Cl minus, then Br minus, then I minus. Okay, any normal student would do like this. This is normal, intuitive. But if we look at the data, what we see, look at this data. It is given in NCERT actually in your chapters. Look at H minus's size, 208 picometers. F minus is 133, Cl minus 182, Br minus 196, I minus is 220. So what we infer? What will be the real trend? I minus will have the largest radius, 220, then H minus, then Br minus, then Cl minus, then F minus. Okay, so H minus is actually very large in comparison to H or hydrogen, and that is very actually small. It's actually a small atom, but H minus is actually comparable in size to actually iodine minus. It is so big. So you don't, if they give you like this, you don't have to fret. Just remember this, that H minus is actually very large, and this is the real trend. So now we have completed about ionic radius as well. You just revise this. It is very easy, only you have to remember anion is greater than neutral, greater than cation. This is the only thing that you have to actually memorize and remember, and all the questions will be from here only. So revise this. If you have any problems, you should write it down in the comments. Also like this video, subscribe to the channel, and I'll see you guys in the next one.